Good morning and good afternoon to all the colleagues around the globe. I am very happy to welcome you here from Germany, from our live studio, to this online webinar. Today, we will talk about serious problems that your customers already have or may have in the future. And if you do not trust me, just go to the search engine of your choice, put in the header quagga mussel, and you will not read about the characteristics of this mussel species. For example, how big is the mussel, what color does the mussel have, or like 10 best recipes for quagga mussels. No, you will mainly read about problems that this mussel causes. And don't worry, we have a solution for this. And when I say we have a solution, I mean you as part of the HYDAC group, you have as well a solution for that. We saw this need in the market. I would like to introduce myself. Giuseppe Alex Rufino is my name. I work at HYDAC Process Technology in the technical sales department and product management. And me, together with my colleague Friedrich Wilhelm, we saw that there was a need to do something. And this is why we did test trials at Lake Constance. And we would like to present our results and the solution for this problem of invasive mussel species today. Our agenda will be, first of all, we would like to introduce you to the topic. What is the initial situation? What does this mussel bring? Which problems do they bring to the customer, and how are we able to solve them? Afterwards, we want to show our test results, because we thought we do not only want to promise things, we want to prove things. And therefore, we did a long-term test trials. And of course, we want to share these results. Before talking about companions or competitors, there is a theory in the market. A theory where they say the larvae can be killed by shear forces. And we want to show you, is this really a theory or is this maybe a utopia? After that, we will talk about the markets, how to develop the market, what applications are there, what are your chances and possibilities. In the end, a conclusion and a nice discussion. By the way, talking about discussion, this is a live online webinar. I would ask you to, if you have any questions, put them in the chat. We have a back office and we will collect the questions and answer them afterwards. Okay, with no further ado, let's start with the quagga mussel. As you may know, many customers already have a problem with zebra mussel, and the zebra mussel is more and more being displaced by the quagga mussel. And this is why I want you to help to recognize this mussel when you are on site of your customer. The quagga mussel is brighter compared to the zebra mussel. The quagga mussel is a little smaller than the zebra mussel, and when you have a frontal look, it has a more elliptical shape instead of the typical triangle shape of the zebra mussel. Its origin is from the Black Sea, and from this region it was spread all around the world. How was it spread? Mainly via ballast tanks, before the ships or boats had systems to treat ballast water. So if you bring water from one region to another region, you as well bring one microorganism from one region to another. And in that new region, these microorganisms do not have any natural enemies. And without having natural enemies, they can spread and spread and spread exponentially. And the quagga mussel spreads really fast, because the quagga mussel is very good at being able to live in every condition. Quagga mussel likes low water temperature, mid water temperature, high water temperature, salty water, fresh water, sea water, lake water, high depth, middle depth, low depth, and so on. The quagga mussel is a king in adapting, and this is why it spreads, and this is why we see more and more problems all over the world. What happens when you have the quagga mussel in your lake and you take water from this lake for maybe cooling purposes? These larvae hatch through the grids or pumps or filters, and when you open a flange after some time, sometimes colonies, like in this picture, can come towards you. Or in the below picture, a butterfly shut-off valve. When you open it, there are many, many mussels. The problem is pretty obviously increased pressure loss, energy loss, higher maintenance costs, and reduced throughput and even system downtime. And no operator, no customer wants to have this. And now a question may be, isn't there any solution for this already? There are solutions. There are already solutions, and they are sometimes sufficient or unsatisfying, but they are not perfect. Why? For example, we have sufficient solutions for killing the larvae with chlorination, ozone, biocides, pH value reduction, UV plants, and thermal treatments. But there are some disadvantages. For example, the costs may be very high, or it's undesirable or prohibited because of ecological reasons. Yeah? Or the system needs to be shut off while this treatment. And this is maybe something that the customer doesn't like as well. Other methods to separate or kill the larvae may be sand filters or backflushing filters like we have some. But the results of killing the larvae, they are unsatisfying. And when we go through this whole table, we see there are solutions, but there is a need for the perfect solution. And when we examined this problem, we saw something that we call the two-stage problem. And for a two-stage problem, for us, it is obvious that you need a two-stage solution. Let's talk about these two stages. Let's talk about these two problems. The first stage is the adult mussels, the problem that may seem obvious to you. The mussel with shells, with a carapace. These shells enter your system or your customer system and immediately block heat exchangers, block nozzles, damage turbines, for example. This is the first stage. The second stage is something more on a mid-term basis. It's not immediately. The second stage problem is the young mussel larvae. Yeah? The larvae, when they enter the system, they settle in the pipe from the 8th day on. The larvae itself, when it's born, it's free-floating, it's elastic, it goes with the flow and may enter the system. And from some day on, from some point on, they build this typical shell and they start to build colonies in the piping system. So what we learned now is we have a two-stage problem, one immediate problem, the shells, and one mid-term problem, the larvae. And if you want the customer system to keep it mussel-free, you must have a solution for both stages. And this is why we say for a two-stage problem, we need a two-stage solution with two filters that we already have. The autofilled RF3 and the autofilled RF14, which together are the autofilled mussel catch. Now in this schematic, we see on the left side a lake or a sea or a river. And on the right side, we have a consumer, in this example, a heat exchanger. And the theory is, if we take water from this lake or sea or whatever, we take a filter cascade. The RF3 for separating coarse particles, mussels and mussel bundles, and the fine filter, the RF14, for the fine particles and for retending the larvae up to 100%. And this prevents colony growth in the pipe system. And this, in our opinion, is the only economic and working solution without having any downtime in the customer system. Many of you already know very well how the RF3 works. Yeah, because this filter we sell since, I think it's 1997. But still, I want to show you how this coarse filter works, because this maybe helps to distinguish this filter from the pretty new RF14 on the one hand, and on the other hand, there may be in this webinar new colleagues that do not know the RF3. Okay, we have the inlet on the bottom left of the filter and the outlet at the top right of the filter. In the inlet, the water comes with particles, and in best case, the water leaves clean the filter on the top right. As every backflushing filter, there is a backflushing line with a backflushing valve and some kind of backflushing device. Every backflushing filter has a backflushing device. In this case, it's the backflushing arm that is under each filter element, each candle, and with the help of the shaft, it's connected to the gear motor. While the water with particles go through the filter elements, the particles are held back on the inside of these filter elements, and by time, the differential pressure grows until a certain point. We call this point the triggering dP. When triggering dP is reached, the control starts a backflushing cycle. Therefore, the gear motor turns the backflushing arm under each element and the backflushing valve opens. By system pressure, it comes to a reverse flow in the element that is being cleaned, and the pollution is carried out of the system. One element in backflushing, the others still operating. So it is filtrating all the time. Now that you know how this filter works, let us have a look how the RF14 works and what is the difference to this filter. When looking from the outside, the filter may look the same. It has an inlet, it has an outlet, it has a backflush line, a gear motor, and a flushing device. But the difference here is how the flushing device is executed. We have here cleaning nozzles. And with these nozzles, with high suction, we can clean the element basket. We have only one basket with a very fine element. My opinion is that the function of this filter can be best shown in an animation. So let's have a short look at this animation. As I told you, inlet at the bottom left, outlet at the top right, backflushing line with a backflushing valve at the bottom right. We have the gear motor and the flushing mask with its nozzles in the middle and one filter basket. The water comes in with particles on the bottom left and leaves the filter on the top right without particles. While doing so, the dP, the pressure from inlet to outlet, increases until triggering dP. The control starts the backflushing, the gear motor turns, the backflushing valve opens, and the pollution gets cleaned, or the basket gets cleaned with very high velocity, very high turbulence. And because of this high velocity and turbulence, we are able to filter much finer compared to RF3. Yeah? Okay. The RF14, it's, let's say, a family. We have the RF14 family for very low flows, 20 cubic meter per hour, up until 4,000 cubic meter per hour. And in this way, we can sell solutions for every type of industry. And for our test filter, we used a bronze cast iron filter that you can see on the left side. So in the middle of this series, we had a jump from cast filters to welded filters. How will this mussel catch be executed? Here is an example picture of how to execute RF3, the coarse one, and RF14, the fine one. Yeah, this is one line, and what is helpful is if both filters have one centralized filter control to control both units. One reason may be because the interlocking helps to prevent simultaneous flushing. This is our, let's say, starting point. Now, together and in discussion with our customer, we need to put up the system. What is not allowed is to use a simple bypass valve, as we often see with filters in general. The reason is these larvae, when they enter the system, upstream of our filter, there are still larvae. When they go to this piping system over the backflushing line, there they have the time to grow, the time to settle, the time to build up colonies. And when our filters go into revision, we open, or the customer opens this backflushing line, and there is a really huge risk of contamination from the first time the valve is opened. This is why we need some kind of a redundant system. The simplest type of this redundant system is to have screen basket filters or inline filters in the bypass line. This is suitable for short-term switching when you have a revision for, let's say, 1 day. And the important thing is that one of the inline filters has the same filtration rating as our RF14, because only like this we can ensure that no larvae go into the customer's system. One other way, which is pretty typical, for example, in hydropower, is to build up a redundant system with 2 lines, and in each line we have our backflushing systems. This redundant solution can be operated fully automatically with the help of one centralized control. And for even utilization, the line can be switched regularly. For example, 1 day line A, 1 day line B, and so on and so on. This may be one solution for your customer. When you have a specific application, come back to us and we talk together and find solutions together how to propose a system for your customer. So far, it was more or less a theory. This was our idea. How do we prevent this mussel larvae to enter the customer's system? But as I said in the beginning, we want to prove it as well. And what we find out is that we are the only competitor who did long-term tests to prove that we hold back these larvae. I want to present now our tests, our trials that took place from April to November in 2024 in Constance on Lake Constance. On the right side, you can see a map of this Lake Constance, and practically everywhere can be found the quagga mussel. In water depth of 10 to 25 meters, up to 25,000 mussels. And if you have a deeper look into the internet, for example, you will find out that every customer, every operator, everyone that takes water from this lake has serious problems. And one who has problems is the University of Constance. There took our test place. The University of Constance wants to implement a new large heat pump in 2027. And they already know this problem of this quagga mussels, and they are looking now for solutions. And we proposed a test filter, our AutoFilt RF14 bronze cast iron version. And the reason why we did this long-term tests was we want to determine the larvae amount upstream of the filter, and then we wanted to count the larvae downstream of the filter. So in best case, we have many larvae in the inlet and no larvae on the outlet, and this would be the proof that we hold back these larvae. We did this, and this was important to us as well, together with an independent immunological institute. The limnology is the science of inland water. And these institutes have proven tests. They know how to do it. And this gives us and you the security that it's a proven system. Some impressions. Yeah? As I said, from April to November, this is our test skid. On the left picture, the insulated line, it's a 16-inch line. This was the main pipeline, and from this we went with 1 inch to our test filter. We had flow measurement, we had data logging, we had regulating valves and so on. And very important as well, these yellow hoses. This was our sample taking, and we took samples on the inlet of the filter and samples on the outlet of the filter, and these samples went into these plankton nets that you can see on the top right. And if there are competitors that say we keep your system larvae free and take a 1 liter sample, this is not enough. The sample taking took place over at least 2 hours, 600 liters, 700 liters, 800 liters. This is the minimum sample taking, because the mid amount of larvae in the Lake Constance, we will see this later as well, is about 1,000 larvae per cubic meter water. This means 1 single larvae in 1 liter. You must have a lot of luck to take half a liter sample and then see a larvae or get a larvae in there. So the correct way to take samples to show that there are larvae is to take at least 600 to 700 liters of water. And this were on a net, and everything that was on this net we put into a bottle, and this bottle was sent to the Limnological Institute, who examined the samples under the microscope. Another important impression you can see on the next slide. Over several weeks of operation, we opened our filter, and what we found was very interesting. Although the university said we have clean water, we take this water for drinking purposes and so on, we found a lot of mussel shells, up to 2, 3, 4 centimeters sometimes. And this leads us to the opinion that a cascade is needed. It is really a 2-stage problem. We cannot put only the fine filter in there, because these big particles are challenging for our fine filter. So both filters are important. Coarse filter for the shells, fine filter for the larvae. Okay, let's have a look at the results. This is the main slide of today, because this is the proof that we hold back larvae. On the y-axis, we have the larvae population per cubic meter water from Lake Constance. On the x-axis, we have the sample number. We have red columns, green columns, and black columns. The red columns show the larvae population on the intake upstream of the filter. And the sample 1 was taken in April, and the last sample was taken in November. So we had a complete testing over the most critical periods of the year: spring, summer, and autumn. As you can see, first of all, the larvae are present the whole year, and with the year going by, the larvae population grows. Okay, now that we know what comes into the filter, let's have a look what goes out of the filter. And here we distinguished between dead larvae and living larvae. We only rarely saw any larvae downstream of the filter, but mostly when we saw them in samples 7, 8, 11 and 12, there were dead larvae. We expect them to be so small that they died so early that they somehow went through our filter element. And in only one case, sample 2, there was one living larvae going through our filter element. And we were really happy about this result because now we can say we have up to 100% retention of the quagga larvae and do not only promise things, we prove things. When you go now with these results to your customers, they will tell you, at least in Germany, it is really often like this. They will tell you, there's an easier way to kill the larvae by shear forces. And then we have to ask them, is this a theory or a utopia? Let me explain you this theory behind it. On the right side, on the picture, you can see the profile of the filter element, the triangle profile. The flow direction here is from the right to the left. And because the area is reduced, the fluid is accelerated, and compared to downstream and upstream pressure, we have a negative pressure. By this, there is a caution of shear forces. And these shear forces, so the theory, kills and damages the larvae. And now I have a question. Can we confirm this theory? And therefore we have done fact checks. Today I brought 3 fact checks, and let's start with fact check number 1 that was done in 2002 with the RF3 in Schwedt, this is a city here, in a refinery. We took water from a river, passed our RF3, and then this water was used for cooling purposes or any other purposes in this refinery. And we, of course, took samples there. And what we saw was that in average, only 45% of the larvae were killed. So in our opinion, this theory cannot be confirmed. Second fact check. Where we did the trials in the University of Constance, there was a competitor filter. And of course, we went to the competitor filter and took samples there as well and asked the institute to look at these samples under the microscope. And what we saw there confirmed what we learned in 2002. We saw larvae, and now we only have a look at living larvae because they say that we have no living larvae downstream the filter. And what we saw was we have living larvae upstream the filter and many, many living larvae downstream the filter. So over 20 years, physics or the science did not change. Even when 20 years passes, still this theory cannot be confirmed. And the third fact check was from an independent drinking water supplier at Lake Constance who published a paper. And this fact check is really important to me because it's not from us. It's not from a competitor. It's not from someone who wants to sell something in the market. It's from an operator at the sea. And now I want to give you a citation. In this experimental setup, however, both inactive and vital mussel larvae, so the dead and the living, were observed in the draining water, so downstream of the filter. This means that these larvae could develop into mussels in the downstream system, which adhere to the surface in contact with the water. Consequently, the use of wedge wire slotted screens is not recommended in this application. We now have three facts that show that mussel larvae cannot or will not keep a customer system larvae-free. Let's have a look at these market companions. No worries, half of the webinar is done. Let's have a look at these market companions. This is a pretty global webinar. There are global players. There may be as well local players that you know better than me. For us in Germany, the competitors are mainly Danko Dinenthal, Boll & Kirsch. In your country, it may be Amiat, it may be Eaton. All of them, if they put focus on this mussel topic, they have documents that say that they can handle this problem. But all in all, we can say the autofilled RF14 is the only filter which has proven its efficiency against mussel larvae with an independent institute, and this over a longer period of time. And when you look at marketing material of the competitor, for example, now, attention, only internal info. If you look now at the filter of Danko Dinenthal, in its marketing kits, you will see these pictures where these mussel larvae go through and then the mussel larvae are destroyed in some kind of way. When you are confronted at the customer with this theory, you can without any doubt say that this theory is not true. And furthermore, here are the pictures of this system. As I said, the place where our trials took place, there were Danko Dinenthal filters. And we even saw mussel shells downstream, so on the clean side of the filters. So you can trust in the products that we have. And without any doubt, you can say that we are the only to prove what we promise. Let's have a look at your application, at your markets. Good news for you. In general, we can say everywhere where protection of system components and water-carrying pipework networks against exponential mussel is needed. And in industries that are already well known to you, in industries where you already have customers, for example, drinking water treatment, heat pumps, paper industry, hydropower, steelworks, and so on, and what applications there, as well applications that are well known with our product, process division products, protection of heat exchangers, fresh water, cooling water, process water, drinking water, and so on. So these are all applications and industries that may be known to you. Just give your contacts a call, tell them, are you aware of this problematic? Do you today already have a problem? And if not, in the future, think of us when you hear something about that. What would I do? I did an example here. I just put into Google quagga mussel plus a location, a lake, a sea, a something that may be in your region. In this example, quagga mussel plus Lake Michigan. And then we already read, we have immediately results if they already have a problem with this mussel or not. I invite you, I ask you to do this for your region, for your lakes in your region. This is a way to do that can be done in 2 or 4 minutes. Can we solve every problem? I want you to be aware what problems can be solved and what not. And we distinguish between critical applications and non-critical applications. A non-critical application is an application that we, for example, had at Lake Constance. We have low solids loads, we have an intake, an extraction tower pretty deep in the sea or the lake, we have a suction basket, at, let's say, 20 to 60 meter depth. Yeah, there we expect only mussel shells, larvae, cloudy material and other microorganisms. This is a non-critical application where we can pretty easily put in our cascade, our autofilled mussel catch that I've shown to you. How could a critical application look like? As you can see in this picture, we have a very dirty river, a lot of organisms, a lot of plants, a lot of fiber-like pollution. This may be critical. Here we need an individual consideration. I will not say that we cannot handle this, but we need to take a closer, a deeper look, contact us and we will discuss it, and afterwards we can tell the customer we can do it, and if we do it with a 2-stage or even a 3-stage solution and so on. What I would ask you to do is to get some information. Pretty much as usually, the operating data, for example, pressure, flow, temperature and so on. Then a system diagram or a PNID can be helpful. Water analysis, when you are on site, like I did here in this example, go down to the extraction point, take your water samples. This water sample is not to determine the larvae, it's to size our solution. Yeah. Okay. Furthermore, we have a filter questionnaire. You can find this filter questionnaire on the below given link in our intranet. By the way, the complete mussel marketing kit is already in the internet and can be found. Market development. How should we work in the market? And first of all, I want to tell you, work together with one company that is part of our company, Funke. They do heat exchangers, and the combination of heat exchangers and backflushing filter is really common. So if we have a project or know about a project, tell them, and if they have a project, they should tell us, and together we have high synergy effects. Yeah. Then I want to explain you what we did. As I said, the University of Constance will build a heat exchanger, a heat pump with heat exchangers, and these heat exchangers needs to be protected. What did we do? A part of only our test trials. We did a concept, a 3-line concept here, line A, line B, line C. 2 lines always operating with 50% of the flow and 1 line in standby for redundancy. Then we contacted the plant manufacturer, the operator, and specifically the engineering office. And by doing so, we were able to have an impact on the tender text. We had an impact on the specification. And of course, the specification fits pretty well to our products. And this is a way to go as well for you. So this picture should be well known to you, as many of you are from sales. We need to have contact to the plant manufacturer. We need to have contact to the end customer, and we need to have contact to the engineering office. In collaboration with Funke heat exchangers, we can try to have impact on the specification. We can try to have impact on the tender text. And then we are in pole position to sell our products. Conclusion. What are my, not last words, because then we will have a discussion later, but what are the last information I want to give to you? Our customers want to have the autofilled mussel catch. Maybe not today, but maybe tomorrow. This is why it's important for you to know about this. Yeah, they want our autofilled mussel catch because they will be looking for cost-effective alternatives to UV irradiation and ultrafiltration, because maybe they are not allowed to use chemicals or biocides because they significantly reduce time-consuming maintenance. For example, if you may know how time-intensive it is to do a revision on a plate heat exchanger, because expensive pigging is no longer necessary, or maybe not even possible. The system components function longer, a lot of pump energy can be saved, and the heat transport of, for example, heat exchanger is significantly more efficient. All in all, a lot of money can be saved, and this is why we are interesting for our customers. And how much money can be saved, we tried to calculate in an ROE. So this example suits only for one region in Germany. In your country, it may differ. But if you want to calculate it, come to us, we can help you. In our example, the example at Lake Constance, for a flow rate of 440 cubic meters per hour, we propose a 3-line solution as explained before. The acquisition costs of only the fine line, because the coarse line they always need for heat exchanger. So we had a look only on the upgrade, the fine line, were 88,000 euros and the operating costs were 7,000 euros. The saving potentials are mainly reducing the power because of reducing dP, improving the heat exchanger of the plate heat exchanger, and last but not least, preventing only one revision of the plate heat exchanger. And there, for these 3 reasons, they have a saving potential of 31,000 euros, which means that the customer pays itself within, or this solution pays itself within 44 months, and 17.5 tons of CO2 can be saved per year. As I said, if you want to calculate this for your region, for your customer, come to us and we do it together. All in all can be said, as I showed, there is a large market potential already today, but if not today, maybe in the future. We have top benefits, we have the products, we have the long-term trial as only competitor on the market. We have sales documents already available in the intranet. So start calling your customer and come back to us and let's plan a solution. Therefore, I invite you again, contact me or my colleague Friedrich Wilhelm or any of my colleagues that support your region or your country, and we may find solutions together. Thank you very much for your attention. I am really happy that you are here, and now I'm excited to see your questions. So the first question comes from Leah. Hi, Leah. So the question is, with other applications, we have a limit of the contamination level to be handled by R3. Does the same apply to mussels? So I would say the limitation is like it's usual with backflushing filter, the TSS and the process parameters. If we have only 1 bar, it's impossible to operate our filters. If we have a TSS load of 400 milligrams per liter or ppm, then it will be very difficult as well. So I would say there is a limit of contamination, and I would say the limit of contamination is, it's always difficult to say a number, but let's say, let's keep it below 100 milligram per liter. Any tests to be done on water? Yes, samples are always good, as I said. Next question is by Swart Martin. What filter grade would you need in the RF14 to stop the larvae? Thank you for this question. This is a very good question. And I'm really happy because this shows to me that you paid a lot of attention. I never said said or mentioned the filtration rating of the fine filter. And this has a reason. Within 6 months in our trials, we had to determine the perfect filtration rating to hold back the larvae. And we do not want to show this know-how immediately to our competitor. Because if they want to do so, they have to do their own trials over several months. So my answer to that is we have a filtration rating that is perfectly adapted to hold back the quagga larvae. Is there a recommended distance between the RF3 and the RF14? In our opinion, maybe I show you the picture again. This is a solution on the top right that we are already offering, and there is at maximum a meter between these two filters. But I think to bring the question in another way of thinking, can they be as well far away from each other? Yes. It is only important to keep the mussel shells, the carapace, out of the RF14. And if there is 10 meters, yeah, so what? And if the customer already have a coarse filtration, so what? That's good. We do not need necessarily the RF3. Yeah. I hope this question is answered. As far as I can see, the question from Schulzken was the last question. Again, I want to thank you all for joining this webinar. I hope it was exciting for you, understandable for you. In case it is not, Leah, there's the last question. Is the PowerPoint available? Not exactly this PowerPoint, but we have a PowerPoint for you and your customers that you can present. Furthermore, the presentation, we have a one-pager. We are establishing a complete kit. Yeah. Any thoughts on recommendations for customer to clean out current pipes infested with mussels? Yeah, this is a difficult question. Not with our filter solution. If a customer already have mussel colonies in the system, they can handle it with heating up, with chemicals, and so on. This when they already entered the piping system, it will be cost expensive. Yeah. Ralph, another colleague from the US, Ralph Rosenkrantz, has there been any testing with other materials for the element in the RF14? With other materials, no. We tested several filtration ratings, but always the same material. Important for holding back the larvae is the filtration rating. And yeah, we have possibilities to execute the filter element. As you already know, plain screen basket or delta mesh, we tested it with both. We have different steel qualities. Yeah. Okay. Is RF14 strainer element available with super flush as an option? This is as well a good question. As you already know, the RF3 is possible to execute with super flush for organics. The answer here is we did not examine this exactly. I think it may be possible and it may be a topic in the future. But the thing is, the RF14 does not really struggle with organics, with sticky pollution. So there is no real need to go into super flush elements. This is why at the moment there is no super flush available. You're welcome. Okay, hopefully every and each of your questions are answered. I really enjoyed to do this online webinar, and hopefully we have soon a chat or a call about any mussel application. I really wish you a great rest of the week. Take care. Bye-bye.